So last thing we're going to look at is 2.1 part 2. And it's, again, as I said before, finding two things. One of the formulas we're going to look at is finding area, and the other one is finding arc length. Okay. We're going to start with the arc length one. Okay. To figure out how to find the length of an arc, okay, which those arcs are what's in red in that picture, we're going to use this diagram. So in the diagram, I've labeled a couple things. So theta, that represents a Greek. That's a Greek letter. I might have said that before. I'm not sure if I mentioned that. But a lot of times when we do trig, when you don't know an angle, they use a Greek letter to represent it. So theta is my first angle, and then S is the arc that goes with that angle. That's an S. Theta 1 is another angle, and S1 is another arc. S1 goes with theta 1, S goes with theta. And R is the radius of the circle. Okay, so any questions on that? Theta. T-H-E-T-A. All right, so what I want to look at first is the connection between the size of this angle and the size of that arc. I want to see how they're connected to each other. So let me draw a circle. Let me put an angle like this. And then here is the arc that goes with that angle. Okay, how big is that angle? 90 degrees. Right, so that's a 90-degree angle. And the arc that goes with it takes up how much of the circle? A quarter. Takes up a quarter. So if you draw a 90-degree angle, you're going to make an arc that's 1/4 of the circle. All right. So now let's do it again. Draw a circle. Now I have that angle. And I have that arc. Okay, how big is the angle in blue this time? 180 degrees. It's 180 degrees. And how much of the circle does the arc take up now? Half. So a 180-degree angle will create an arc that takes up half the circle. I guess I could add up in here. Arc is half of the circle. The arc is 1/4 of the circle. Okay, so let's look at these two pictures. What happened to the size of the angle in picture 1 compared to picture 2? The size doubled. The size of the angle doubled. It went from 90 to 180. Now I want to look at the size of the arc. What happened to the size of the arc in picture 1 compared to picture 2? It also doubled. So what that means is arc size and angle size are directly proportional. If you change one, the other one changes exactly the same way. If you were to triple the size of your angle, you would be tripling the size of the arc. If you make the angle half as big, then you make the arc half as big. Okay, so the point is the size of the arc changes directly with the size of the angle, and that's called directly proportional. So I'm going to write that down. So, actually, let's do it. Yeah, that was fine. Arc size and angle size are directly proportional. Not everything is like that. Just because you increase one thing, it doesn't always mean something else increases at the same time. But with arc and angles, it does. Right. So because they have a relationship where they're directly proportional, what that allows you to do is create a proportion. Right? And by creating a proportion, we're going to be able to figure out the formula for the length of the arc. Now, when you create a proportion, you have two fractions. Okay? You got one like this, you got one like that, and what's between them in a proportion? An equal sign. Now, when you have a proportion, one side has to be filled in, at least the way we're doing it. One side has to be filled in with something you already know is true. Right? So we're going to have to put something we already know on one side. And then the other side can be the stuff you don't know. So like, let's say you were trying to figure out how to convert seconds to minutes. What's something that's true between seconds and minutes?
60 seconds equals 1 minute.
All right, so 60 seconds is 1 minute. Now if you say, all right, how about 430 seconds? How many minutes is that? Well, on this side, I can fill in 430. I put X minutes, and then I cross multiply to solve it. The whole key, though, is this. If you don't know that, you're stuck. Or something equivalent to it. You could put 120 seconds in 2 minutes, but you have to know something already. Okay. All right. So let's see if we can set up our proportion. And then, once we do that, we're going to have to know something already, and it's going to connect with yesterday. All right, now we're not setting up a proportion for seconds and minutes or inches and feet. We're setting up a proportion with angles and arcs. So we're going to use these four things in the proportion. Now there's lots of ways we can set it up, as long as however you do it on the left, you do it on the right the same way. So let me start with the left. Let's do this one. Angle over arc. So how do I have to set it up on the right?
Angle over arc.
What is it?
Angle over arc.
I got to do angle over arc again. What's the other angle?
Theta.
Theta. And the other arc?
S.
S. Now this is going to have to be the side that we fill in, like 60 seconds in 1 minute. We have to put something true on this side. It doesn't matter what we put, as long as it's some true fact. So when we did the seconds and minutes, we did 60 seconds in 1 minute. Could we have done 120 seconds in 2 minutes? Is that also true?
Mm-hmm.
Yeah, we could have. So what you pick here, there's a few different things you could pick. But we want to try to pick the simplest thing we can. Okay. Let me go back to yesterday for a second. Something special happens to make this exactly 1 radian. Does anybody remember? Well, actually, let me say it a different way. If this arc came out exactly the same size as that, does anybody remember what happens? If the length of this and the length of that are the same, it means something about that. Yep.
It's the same length as the arc. It's the same angle number as the arc is long.
Okay, so on a unit circle, we talked about that. I'm thinking more general. It was even before we did the unit circle. It was the very first thing I showed you about radians. If this arc and this radius are the same size, you automatically know how big that is.
45 degrees.
We didn't do anything in degrees to figure this out yesterday. Yep.
Doesn't it mean it equals 1 radian?
It means it equals 1 radian. So if this is 1 radian, it automatically makes the length of the arc the same as the radius. That's the true fact that we're going to use. That's like our 60 seconds in 1 minute. An angle of 1 radian, by definition, means arc equals radius. That's automatic. That's the definition. All right, so if that's 1 radian, then it means the arc is going to be the same size as the radius and they're going to tell you the radius of the problem. That's why that's helpful. Okay, so now fill in everything you can on that side. Fill in your true fact. An angle of 1 radian automatically means an arc that's the size of the radius. And now the other side, you don't fill anything in. That's where you put the information from the problem. So leave the other side. And now the goal is to get the S by itself. How do you solve, I think I said it already, but how do you solve a proportion? You cross multiply. What's S times 1?
S.
So S, and then how about R times theta? R theta, just R theta. I think I have that already written right down here. Nope, I don't. So that is the formula for finding the length of an arc. Now, if you didn't know this fact on the left-hand side, that's like not knowing in 60 seconds there's a minute. You're going to be stuck. Okay, we had to fill something in that was true. Is that the only thing we could have filled in? No. But it's something that we knew, and we filled it in. Okay, so S, that's the arc length. R is the radius of the circle that you're drawing this in. And theta, that's a Greek letter. What did I say Greek letters usually represent? Represent angles. But what about the angle?
You don't know it.
Well, what did we assume when we filled in our fact on this side?
Radian.
We filled in 1 radian for our fact. Right? Like in this formula, you filled in seconds. So this formula is about seconds now. So it assumes you're going to put seconds here. You put 1 radian here. So when you fill your angle in, you need to put radians. So your angle in that formula has to be in radians. Okay, the way the formula works, they'll always give you 2 out of 3 things, and then you'll solve for the 3rd variable. So you might know the S and the R and the theta, or the S and the theta. Okay. Any question on the arc length formula? All right, let's try. Okay, so find the length of the arc. So there's a couple ways they can give you a problem like this. They can write a description out, describing the problem. So in this problem, they're telling you that you've got a circle. The angle that you're drawing in the circle is pi over 3. And the radius of the circle is 4. If you want to see it as a picture, I did that. Oh, I didn't do a picture. Oh, I could do a picture. There's a circle. You got an angle of pi over 3. It's not to scale. Okay, so there's your angle. And you have a radius of 4 inches. The goal is to figure out how long is that piece in red. That's the length of the arc. So you don't need a picture to do it. You just need the formula. S equals R theta. Okay, so let's go through it and start filling in what we know. Okay, do we know S?
Yeah. Yes.
Yes? Okay, what's S?
Well, actually, we don't know S.
No, what is S?
Angle length. I mean, arc length.
S is the arc length, and that's what the directions are. Find the arc length. So, S, we don't know. What about R? Do we know that?
No.
Yes.
Yes.
Yeah, if we don't know one thing, I hope we know everything else. we're gonna be stuck if we don't. So, what's my radius?
4 inches.
So 4. And do we know the angle? pi over 3, and the angle's supposed to be in what? It's supposed to be in radians. Is our angle in radians?
No. Yes.
Yes.
Yes,
Yeah.
it is.
Yeah. There's no degree symbol.
Yup, it's in radians.
So it's in radians.
I knew that. No, I didn't.
You're
So
doing
you-
good. You're
If
doing
it wasn't in radians, off to the side, we'd convert it radian. Okay, now we just multiply these two together. If you want to think of 4 as a fraction, you can. And just go straight across. So 4 times pi gives me 4 pi over 3. Now, what did we just find?
the length of the arc.
The length of the arc, right? Find the length of the arc. So we need to put an appropriate label on this. It's a length. So what do you think the unit should be?
Inches.
In this problem, it should be inches. Okay. Whenever you're solving for S, that's a length. R, that's a length. Theta, no, that's an angle. So any question why we put a label of inches? Is that
Is it ever gonna change? Like, is it gonna become feet at some point?
yeah, it could be different inches, feet, things like that.
So just whatever it is, kind of keep the labels the same.
maintain the unit of measurements. You gotta keep the same length. Yeah.
Sounds good. Excellent.
All right. So this time more of a visual. That's what you're solving for. Yeah. Yeah. Okay. So what's the formula that we're going to use?
S equals R theta.
So definitely we need to know that.
Well, for me, for me, it's better.
Now it says find the length of the arc. So what letter are we solving for? S. Yep. So we're solving for S again. Okay. Do we know the radius?
8 feet.
Yeah. So the radius is given in that picture as 8 feet. Okay, it's definitely not a diameter. I would have to draw the line all the way across. So that's 8 feet. Okay, do we know the angle?
No, kind of.
What do you mean?
Well, it's in degrees. We need it in radians.
Yeah, it's in degrees, so we need to change to radians. I'm going to just do that on the side. What do you multiply by to change to
Times
Radian.
pi divided by 180.
times pi divided by 180? And anything that those are both divisible by? 10.
10.
So the angle is 13 pi over 18. Leave the angle like that. Okay, 13 pi over 18. Okay. So now we can reduce a little bit. What goes into both 8 and 18?
Wait. Oh, wait, never mind. Sorry.
2. 2 times 4 gives me 8, and 2 times 9. So the length of the arc as an exact answer. What's 4 times 13 pi?
They multiply?
Well, and I want an exact answer, not a decimal.
52 pi.
52 pi. Yep. So 4 times 13 gives you 52. Pi, that's the top. And what's in the bottom? Divided by 9. And that's a length. So it should be 52 pi over 9 feet. In this problem, feet.
Interesting.
Now, if they wanted a decimal, then you could just type it in. 52 times pi over 9 should be about 18.15 feet.
It's really nice.
Any questions on that one?
No.
Okay, so still solving is the same thing in the last problem. Finding the length of the arc, but you have to fix the angle first. I'd say the biggest mistake some people make, they forget to change 130. Alright, let's try this one. So now it says, suppose we have an arc length of pi over 4 centimeters, a radius of 12 centimeters. Find the angle. Okay. So we got the formula. S equals r theta. Let's start with S. Do we know S?
Yes.
Yes.
Yeah, what is it?
Pi over 4.
The arc length is pi over 4. Okay, let's go to the R. Do we know R? Yep.
12
R is 12.
centimeters.
Yes, it is centimeters. The next one is theta. Do we know that?
No.
No. It's the direction. Find the angle. Okay. So how would we get rid of the 12 and get theta by itself?
Divide by 12 on both sides.
So divide by 12. That's the same as just putting a times 12 in the bottom on the other side. And you divide by 12. So divide by 12 here. It's gone. And what do we get when we divide the left side by 12?
Pi 36 equals theta. Oh, pi of 36. No, 48.
48.
Jeez, wow.
So that's theta. And let's see, should we put a label of centimeters on it?
Yes. Not yet.
No.
Not yet.
No,
Why?
because theta is an angle, and angles don't have lengths.
Yeah. That's theta. Theta is not measured in inches or centimeters. It's measured in radians. And you don't put RAD. You just leave it just like that. Okay, so any question on that?
So if it wants like the specific, like exact number, then it's gonna say it in the problem on the test.
Yeah, it'll say, find the exact answer, or it'll say round to 2 decimal places. Yep. This one didn't say, so.
Yep.
All right, so we've solved for S, we've solved for theta. Let's try one where we solve for R. Okay, so this time we don't have a description, it's just a picture. We've got our angle, we've got the 13, we've got the R. The first thing we should write down is the formula. Right, so it's easy right now because we've only learned one formula. We're going to learn the second formula in a minute. That's for area. Okay, but right now, the only formula we know is which one?
Arc length.
The arc length, and what is it?
S equals R.
Theta.
Okay, do we know S?
Yes.
Yeah.
13 feet.
13 feet. Okay, if there was confusion what that's labeling, I would clarify, but the 13 is on the outside, and that's representing the arc. Okay, do we know R?
No.
No.
Nope. So we're going to leave that as R. And what about theta?
36 degrees.
It's 36 degrees,
But it needs to be converted to radians.
but it needs to be converted to radians. Yep. Okay, so how do we convert that to radians?
Multiply it by pi over 80.
Pi over 180. And does anybody see what both of those are divisible by?
36.
They are both divisible by 36. 36 times 5. So what is 36 degrees?
Pi over.
Pi over 5. Yep. Okay. So is the R by itself right now?
No.
No. Well, that's the goal. We need R by itself. So we want to get rid of the pi and the 5, and we can do both at the same time. Does anyone remember what you could multiply both sides by to get rid of pi and 5?
5 over pi.
Yeah. Remember what that's called?
No.
The reciprocal. Yep. So when you have two things you want to get rid of, and it's multiplied by a letter, you multiply by the reciprocal, which is 5 over pi. So 5's cancel, because there's one in the top and the bottom. Pi's cancel. And now all you're left with on the right side is R. And on the left side, what's 5 times 13? 65. Okay, what did we just solve for? R, which is, and the radius. The radius is a length, so it needs a label. The label on this one would be feet. And if they ask for a decimal, 65 divided by, and how do you type in the bottom?
Just like roughing
Yep.
Arrow.
So don't do 3.14. So it's about 20.69 feet. Okay, so that's the arc length. Any question on that formula?
No.
All right. So the last one we're going to look at is transitioning to finding area. Well, area is this. Now that shape is called a sector. Why not a triangle?
Because it's part.
Because it's an arc, not a straight line.
Right. Yeah. It's more like a wedge of like pizza or something. If you cut it into like slices, 8 slices or something, a circle. It's the third side isn't straight. It's an arc. Okay. So that's why you can't use the formula for a triangle. All right. So we're going to figure it out exactly the same way we figured out the arc length formula. Okay. I'm not going to go through the same. Actually, I can just bring up the same diagram we did before. But instead of focusing on the length of the arc, focus on the area shaded in green. Everyone agrees we doubled the size of the angle still from picture 1 to picture 2? Yep. Okay. Now, we said the arc was a quarter of the circle, but now how about the area? How much is the area here? The area is also a quarter, and the area here is half. So when you doubled the size of the angle, what happened to the size of the area?
You also double.
It also doubled. So if you triple the size of this angle,
Directly.
you would triple the size of the area. So angle size and area size are directly proportional. So I'm going to write that down, but I'm going to put area instead of arc. Okay. Area, a sector, and angle size are directly proportional. And because they are directly proportional, that means we can set up a what? Proportion. A proportion. If they are not proportional, you cannot use a proportion. That's how it works. All right, so let's set up a proportion. We have to fill in 4 things first, and then 2 of them, well, we have to fill in something we already know is true. All right, so these are the four things we're going to fill in. Let's start with these 2 on the left side. Can somebody tell me how I could fill those in on my proportion? Like what would go in the top and what would go in the bottom?
Theta 1 over A1.
Okay. Theta 1 over A1. You could have also done A1 over theta 1. As long as you set the other side up the same way, it'll work. So because we put theta in the top on the left, it has to go in the top on the right. So what has to go on the right side now?
Theta. Theta over A.
Theta over A. Now this side, you have to fill in something that you already would know to be true. Right. So let's think about the connection between the angle and the area. Go back here. When I drew an angle of 90, how much of the area did it take up?
A quarter.
Okay, a quarter. How about when I drew an angle of 180? Half. Well, let's draw an angle like this. Here's my terminal side. here's my initial side. So let's say I brought the terminal side all the way back around to where the initial side started.
360 degrees.
So that's 360 degrees. And 360 degrees gives me an area of how much of the circle?
1%.
Yeah, the area is the entire circle. So any questions why a 360 degree angle gives you an area of the whole circle? That's the facts that we're going to use. If you have 360 degrees, the area is automatically the whole circle. That's a true fact. So let's think about that in radians. How much is 360 degrees in radians?
2 pi.
2 pi. Now, when the area is the entire circle, we already know a formula to find that from geometry. What's the formula for the area of a circle?
Circumference.
No.
Area equals your diameter times pi.
That's circumference.
Oh, crap, that's right.
Anyone remember formula for area of a circle?
A equals R times pi.
Radius squared times pi.
Radius, yeah. So this is the true fact that we're going to use. If you make the angle 2 pi, you automatically make the radius, you automatically make the area the whole circle. So an angle of 2 pi means an area of pi r squared. And that's just from geometry. We're not going to prove pi r squared. Let's fill that in our formula. All right. So let's suppose that our angle is 2 pi. What did we just say that makes the area? Pi r squared. That's the true fact that we're going to start with on the left, and that'll allow us to figure out anything that we want to know. All right, let's fill it in. So we have the angle is 2 pi. The area is automatically pi r squared. And now the right side, you leave it alone. That's where you'd fill in the stuff from the problem. Okay. So how do we solve a proportion? Cross multiply. This time the goal is to get a by itself. Anything I can do before I cross multiply?
No.
Well, probably wouldn't ask if I wasn't hinting at something you could do.
Yes, you can.
Yes, you can.
You're a pi.
You can get rid of the pi's. You have a pi in the top, pi in the bottom. So the pi cancels out. All right. Now, what do you get when you multiply what's left on that diagonal?
2a.
2a. And what about this diagonal?
R squared times theta.
R squared times theta. All right. And now we don't want a formula for 2a. We want a formula for a. So what's one way you can get rid of the 2?
Divide both sides by 2.
Yeah, you could divide both sides by 2. Or that's the same as
multiply each side by 1/2.
or multiply each side by 1/2. And that's generally how our book writes it. So that's the area of a second. It's 1/2 r squared.
We had to put in a cube then.
Okay, so 1/2 r squared theta. That's the formula for area of a sector.
Nice.
So remember, A is area, R is radius, and theta is the what again?
Angle.
The angle.
In radians.
And again, the way we built this formula, we built it with radians. So it's a radian formula. If you wanted it in degrees, well, it wouldn't have been as a formula to do in degrees, because if you had a 360 in the top instead of a 2 pi, then the pi's wouldn't have canceled out because there wouldn't have been one. So the formula would have been messy if we did it in degrees. It looks a little simpler in radians. Okay. Any questions on that? All right, let's try an example. So example 5 says find the area of the sector. All right, start with the formula. What's the formula for the area of a sector? Yep. Yeah. Do you know the formula for the area of a sector?
1/2 times r squared. Oh,
Yeah, you have it. What is it?
1/2 times radius squared times, is it 3?
The Greek letter, which is theta. Yeah. So area is 1/2 r squared theta. Yep. Okay. Now let's just fill in what we know. Okay. Do we know the area?
No.
Nope. That's the question. Find the area. So we got 1/2. Do we know the radius?
Yes, 4 centimeters.
4 centimeters. And do we know the angle?
Pi over 6.
Pi over 6. And is that the way we want it?
Yes.
There's no degree symbol on that. Okay, so make sure you follow order of operations. So exponent, what's 4 squared?
16.
And then half of 16?
8.
So it's 8 times pi over 6. Which reduces to
4 pi over 3.
4 pi over 3. And what did we just solve for?
Area.
We just solved for area. So what should be the units on this?
Centimeters squared.
Centimeters squared, yes. Area is 2-dimensional. Square centimeters.
Sorry, it's snowing outside.
Yeah.
My ADHD. I just looked down like.
How's that? If they wanted a decimal, you just type it in on the calculator and change it to a decimal. Questions on how we got that?
So what you did was you took 4 squared 16 divided by 2 would be 8 times pi divided by 6. And then just simplify.
And then I just simplified it. Okay, a little different. This time, instead of finding the area, well, we know they're giving you the area because they're giving you a number with square inches on it. So that's an area. But they're giving me an angle that's 45 degrees. So what do we got to do with that?
You gotta change it to radians.
Got to change it. And 45 is a common one. Does anybody know what 45 is?
1 second. Is that
5.
1/2 pi is 90.
pi over 4?
It's pi over 4, yeah. Pi over 2 is 90. Pi is 180. All right, so let's fill it in. So area is 1/2 r squared theta. Okay, what's the area?
8 pi over 3.
8 pi over 3. What's the radius?
We don't have it.
We don't know. That's the question. Find the radius. And what's theta?
Pi over 4.
Pi over 4. Okay. So the goal is to get the r by itself. But a couple things we have to get rid of. Let's start with the pi over 4.
Multiply that reciprocal.
Yep. What's the reciprocal?
4 over pi.
So we can multiply by 4 over pi. 4 over pi. That cancels the pi's and the 4's. And now let's think about this 1 over 2. You can kind of get rid of that the same way. How do you get rid of 1 over 2?
Times 2 over 1.
Yeah, times 2 over 1, or just times 2. Times 2 over 1. times 2 over 1. 2 in the bottom, 2 in the top. What are you left with on the right side now?
R squared.
Still have r squared. But on the left side, you can reduce anything that cancels out completely.
Pi.
Pi's gone. What's 2 times 4? 8 times 8?
64.
So 64 over 1 times 3.
1 times 3?
Yeah,
3.
3. Now, is that the radius?
No.
No, that's the radius squared. So how do you get rid of squaring? Take the square root. And when you square root a fraction, you do the top and you do the bottom separate. Now, the top is going to be okay. What's the square root of 64?
8.
So that's 8. That's good. But there's a problem with that. What's wrong with that as a final answer?
Cannot have a square root in the denominator.
Right, we're not supposed to leave the square root in the denominator. So as far as like trig and the formula for the area, we're done with that. We're just fixing this so we don't leave the square root in the bottom. Does anybody remember how you fix it so the square root's not in the bottom?
U squared. So, no, you lose it.
Well, you do have to multiply by something, but what's the only thing you can multiply a fraction by and it doesn't change it?
1.
1. So you have to multiply by 1, but in a special way. 1 just means the same thing over the same thing. That's all 1 means.
Square root of 3 over the square root of 3.
Right. You have to multiply by the square root of 3 over the square root of 3. You might think, well, why? What does that do? It's just multiplying by 1. Multiply straight across. 8 times the square root of 3 is the square root of 3. 8 square root of 3. And the square root of 3 times the square root of 3 is the square root of 9. What's the square root of 9? 3. That is how you leave your final answer. And that's the radius. So we're looking for what as a label?
Inches.
Inches. Just inches. Not inches squared. It's not an area. Okay, so sometimes when you have to solve for the radius, that one can be a little bit longer because you got to fix the square root. If this had come out to like the square root of 4 in the bottom, then none of this would have happened. You would have been able to simplify it and get 2 and been done with it. But square root of 3 doesn't work that way. Okay, any questions on that? All right, so that's solving for the radius. We did solving for the area. Let's finish up with solving for the angle. Okay, so how about Alex? What's my formula for the area of a sector? Owen, why did I call you Alex?
Oh,
I'm sorry, Owen. Yeah. Someone help him. Who's got it written down? A equals. Christian, you got it?
A equals 1/2 r squared times theta.
All right. And now fill in what you know. Okay, what's A?
Pi over 2.
Pi over 2. The 1/2, that just stays. How about R?
3 squared.
3 squared.
9.
We could have just written it as 9, or if you want to write it later, we can do that. And what about theta? We don't know theta. That's the question mark. That's what we're going to solve for. All right. Okay, order of operations. What do you do first on the right?
Exponent.
Exponent. So what's 3 squared? 9. And leave your answer as a fraction. It's going to be a lot easier. What's half of 9?
4/2.
Leave it as a fraction, though. 9 over 2. Yeah. Because now, what are we going to do on both sides? Multiply by what? 2 over 9. So leaving that as a fraction is a lot easier than dealing with 4.5. Because 2's cancel, the 9's cancel, and what else cancels?
The 2 on the other side.
The 2's on the other side. Yep. So what am I left with on the left side?
Pi over 9 equals theta.
Pi over 9 equals theta. Yeah, so some of them are a little bit shorter, like that. Any question on that? All right. So in the homework, there's going to be a couple questions about area and arc that are more of like a description. And one of them is going to be something about like finding the length of the arc as the minute hand travels from like 12 to 5. Well, kind of already gave you a hint there. As the tip of the minute hand travels, what kind of path does it make? It makes a what?
Arc.
Makes an arc, right? So as the minute hand travels, it's going around part of a circle. If it does the whole thing, it would be the whole circle. But that's an arc from 12 to 5. Now, to find the length of the arc, you need to know two things. What are the two things you need?
You need to know your radius and you need to know your angle.
Yep. So on a clock, if that was the minute hand would be your what?
Your radius.
That's your radius. Okay, the length of the minute hand. That's the radius. Now, how would you figure the angle out from 12 to 5? Because you're going to have to figure out that angle.
Well, you already know that 12 to 6 would be 180, so you could.
So 12 to 6 is 180, yeah.
And 12 to 3 is 90.
And 12 to 3 is 90, yep. So if 12 to 3 is 90,
Oh,
how much is
360 divided by 12.
how much is each hour?
30.
30, yeah, 360 divided by 12. So every hour is 30 degrees.
Yeah.
So how many degrees? We need radians, but we can do degrees to start. How many degrees to get to 5?
150.
Right. So your angle is 150. You just need to change that to radians, and then you're good. Another one they're going to give you is, I think it's about a pendulum. Okay, as a pendulum swings back and forth, what kind of path does it make?
An arc.
It makes an arc because it's fixed. That's a pendulum. It's fixed at the top and it swings. So it makes an arc. To find how far back and forth it's swinging, the arc, you'd have to know the radius, which in this case would be what?
The length of the string it's suspended on.
Yeah, it would be the length of the string that the weight is hanging on. That's your radius. And your angle, they'd have to tell you, like the pendulum is swinging back and forth 30 degrees. Okay, they'll tell you that in the problem. So those are
Now when it says swing back and forth, does it mean from the center so 30 degrees that way and 30 degrees that way, or 30 degrees in total?
no. If it says it's swinging back and forth 30 degrees, that's the whole swing,
Okay.
not half the swing. Yeah, the whole swing. Any questions on that? Yes.
What information do we need for the clock one again?
What's that?
What information do we need for the clock one again?
Well, you need to know the length of the hand, and then you need to know. They're always going to give you a nice amount, like from 12 to 5, or something like that. They're always going to have it stop on a number. They're not going to have it be like in between the numbers. So the angle and the length. Kind of an interesting problem, but a little bit harder than you might think, is to figure out when the hour hand and minute hand would be exactly on top of each other. It happens 12 times a day. Well, I guess it actually happens every hour, so it happens 24 times a day. But if you don't include AM and PM, the minute hand and hour hand are exactly on top of each other 12 different times a day. The first one is noon. That's the easy one.
Mm-hmm.
But the next one is not 105. Because at 105, the hour hand is no longer on the 1 anymore. Right? The hour hand has gone past a little bit, and the minute hand is at the 5. So it's a little bit later than 105. It might be like 106 or something. But there's a way to figure out all the times not related to what we're doing, but just kind of another interesting question to figure out.
Well, let's just did 2.
All right. So for tonight, the homework on page 99 is 71 to 87, and 91 to 94 odd. Okay, but the 71 to 87 is odd. Okay, you've got just over 15 minutes or so. What I'll do is I'm going to pause there and put the test topics. So I'll